Hi everyone. Today I explain you the bivariate distribution and the content are two-dimensional random variable, probability function and properties, relation of a joint function and marginal function, conditional probability, expectation and covariance. All these are studies for two-dimensional random. Let's start the two-dimensional random variable. Let x and y be a two-dimensional random variable which is defined on a sample space S. The value of xy at W is given the pair of real numbers where W belongs to a sample space. Now, notation x is less than a, comma y is less than b denotes the event of all elements W belongs to a sample space S, and the probability of that event will be denoted by probability x is less than a and y is less than equal to b. Here we note, let us consider two events, capital A when x is lies between A to B, and capital B is another event where y is lies between C and D. Then the event A intersection B means x when lies between A to B intersection y when lies between C and D. So when we say the probability of x lies between A to B and C Y lies between C to D is denoted by the probability when X lies between A to B and Y lies between C to D. Now let's explain the joint probability function. If capital X and capital Y are two random variables of which capital X contain n discrete values and capital Y contain m discrete value, then the probability of x comma y, which is also denoted by f x comma y, and is defined as the probability of x equal to xi is for any number, discrete number, comma y equal to yj, which is defined as the x equal to xi intersection y equal to yj. This is called joint probability function and denoted by P of xy. Okay. Marginal probability function. If x and y are the random variable, then the marginal probability function of x is denoted by the probability of x xi, that is x equal to xi is probability of x equal to xi intersection y equal to y1 plus probability x equal to xi intersection y equal to y2 and so on, so on, so on. The probability x equal to xi intersection y equal to ym. Here we fix xi and varies y1, y2 and y3 so on ym. It is also denoted as probability x of xi is pi1, pi2, pi3 and so on pim. Also we can written as summation j equal to 1 to m and pij or is equal to pi dot. This px of xi or says pi dot is called marginal probability function of x. In the previous slide, we studied the marginal probability of x, and similarly, we studied the marginal probability of y. Here, the p of yj is written as the probability x equal to x1 intersection y equal to yj plus probability x equal to x2 intersection y equal to yj. And similarly, probability x equal to x3 intersection y equal to yj and so on, so on. The probability x equal to xn intersection y equal to yj. Here we fix the yj and vary the xi's x1, x2, x3 and so on xn. It is also denoted as p1j, 2j, 3j and so on nj. Here x vary 1 to n. Now we can also written as summation I equal to 1 to n pij. It is also denoted as p dot j, where pyj or p dot j is called marginal probability of y.